Thanks for stopping by for another fun-filled and action-packed episode of Vintage Audio Review. A few weeks ago I was visiting my audio friend Ian, whom if you don't know who he is, you could check out episode number 5. And on the floor in his living room, half apart, was this integrated amplifier. It's a KA-6000 made in 1969 and sold for about $250, and it was their top of the line integrated amplifier at the time. For reference, a 69 Camaro sold for about $3,700. Anyway, he had purchased this at the Audio Hoarder's estate sale, which itself was another episode, number 7 I believe, and he was having trouble with it getting sound out of the right channel, I believe. And he asked me if I wouldn't mind taking a look at it. So I said sure, I would take a look at it, and here it is. It's a really nice unit and it's in really good shape. I would give it an 8 out of 10. The construction inside, which you'll see later, is just fantastic. It was a joy to work on as far as repairing and getting to components, and the way the boards pulled out to make a replacement of the parts easier. It just is just a nice unit. I'm going to turn it on and zoom up so you can see more of the controls here. And it does have a unique feature that I've never seen in a preamp, and I'll point that out in just a minute. Okay, so I'm going to give a tour of the unit, and it has a few unique features, or at least one unique feature that I have yet to see in any integrated amplifier or preamplifier for that matter. Anyway, we have the power control and the speaker control. It can run speakers A, speakers B, speakers A and B, and if you want to use the headphones, it has a separate position for the headphone jack. So it is powered on, and the neat thing I like is that it has the little, these are actually incandescent lights there that tell you what your source is, and here's your input here. We're on the aux, the tuner, phono 1, and it does have a phono 2. And it has a headphone jack and a mic jack in the back. Well, the headphone jack's here, the mic jack is in the back. So when we do the back, I'll tell you about the phono inputs. But the thing that is really unique about it is that for this tone control, this tone mode, I believe they call it, it has an off position, so that would be like direct, so it bypasses your bass and treble controls, which are here. And then it has just your, if you want to do bass and treble, you can adjust both your bass and treble, and whatever you set here will be applied. Or if you just wanted to use this control and bypass this one, and that's the unique part. I haven't seen that before, so I can just use the bass control and forget about this treble control. It's bypassed, it's more pure, I guess you would say. Or if you just wanted to adjust the treble control and keep the bass out of it, it's more pure in theory. I actually measure that later on for you, and we'll see how that actually comes out to be. Anyway, the neat thing about these tone controls is they're actually switches with resistors. So it's a bunch of switch contacts with resistors around on each for the tone controls. It's not a potentiometer like what you have in the volume and balance controls here. So that is very unique on amplifiers, or at least integrated amplifiers or preamplifiers that I have seen, not to have pots for the bass and treble controls. It has some other things for the mode, which is more for the tape selection here, the stereo, reverse, and this mix, that's more for the tape recording stuff. We also have your 20 dB muting here, and these switches are just cool. They're just got a good, solid, old school feel to them. They just feel good. And then you have 40 hertz and 80 hertz low pass filters. Oh, this is your loudness switch, and here is your high filter. It's at 8 kilohertz, and we'll measure that later, and we'll go over the data just because it's kind of interesting. So there you have it. That is the front panel. So obviously this is the rear of the KA-6000. And we'll start off over here with the phono related stuff. Here is your grounding terminal for your phonograph's grounding lead wire. Here for Phono 1 only, you can change the input sensitivity for either 2 millivolts, 0.5 millivolts, or 0.05 millivolts. So the 0.2 millivolts would be for a moving magnet cartridge, and the 0.05 millivolts would be for a moving coil cartridge. This is your Phono 1 input, and these actually are shorts. Here's your Phono 2 input, which is strictly for a moving magnet cartridge. Now this input is for your tape head, which is for maybe a third head on an old school tape deck that you could use for recording monitoring, and it's very low level. It's different than the tape inputs in here for your normal tape playback and record outputs that you would find. Here we have the inputs for a left and right microphone if you want. Here's your tuner input, your auxiliary input. So here are your pre-out main-in jumpers. Kind of neat little guys. And this here is for your tape monitor kind of situation here. This mimics this for some decks that had those DIN cables on them. And here are your A and B speaker wire lugs. They're real nice. You can screw the wire down in there, or maybe if you had a wide enough lug, you could tighten it down around the lug. But they're nice. They're really appreciated. And here is a mono output. So they mix the left and right channels and give you a mono output for putting into a mono amp. They certainly didn't mention that you could use a subwoofer, but you could. Anyway, so that is the back of the unit. Oh, and here are your switched and unswitched outlets. So this is the inside of the KA-6000 with the cover and sides taken off. The output transistors are here and here and here and here, and there's also some driver transistors under here, under this cover. So there's a circuit board under this cover. There is a circuit board under this cover for the tape head amplifier, and then once this cover is removed, there are some more circuit boards here, and we'll see that in a minute. This is the transformer, the main transformer, or the only transformer. And here are your filter capacitors here. I just wanted to spend a few seconds to show you the underside of the KA-6000. And probably the one thing to point out is this is a connector where the main driver board for the output transistors resides. And there are your switches. These have the resistors, your tone and treble switches, so that's right over here. And that's what it looked like. So this is the slot where the preamp board resides. It just pushes in there once you get the wires over here kind of pushed back, and there's some capacitors from another board. But you can see that they did that with that board. So this is the main board here that is used to drive the power amplifiers, and it also is socketed. You can see that down there. It also does have wires which are, there's several of them here that would have to be pulled out, but they do have terminals on them, so they would be easy to get off if you had to remove that board. Let's just go around, and you can see the quality of the workmanship on this guy. And you have your main output transistors are on each side. So here we have the balance and volume control pots. Here are the front switches as well as the socket where the preamp board goes into. And here are the tone control switches with the resistors. So what we're looking at here is the preamp board from the KA-6000. I've removed it from the chassis, And I would like to point out that it was fairly easy to remove because it is just residing in a slotted connector, which is really nice for troubleshooting. There's 11 capacitors, and I will replace all of them, and we'll test them as I go along just to see if indeed one or more of them is bad. If we flip over the back side of the board, I'm really not worried about ESD issues here. So the back side of the board reveals a lot of soldering that has to be removed in order to get the components out. Anyway, we'll see what happens. So what we are looking at here is the preamp output of the Kenwood KA-6000 integrated amplifier. The complaint I got on it was that the right channel was much lower in volume than the left channel. You can see here between the gain difference between the left channel and the right channel is 40 dB about, and if I turn off the left channel you can see a much lower right channel. Now the good thing is the THD is not that bad. The signal to noise ratio on the right channel is not very good, but the THD is not bad, and so there's hope for it. You can also see the 60 Hertz hum is creeping up a bit here, but it's still not outrageous considering the age of the amp. This is just a response at 1 kilohertz, and I'm curious to see what happens when I sweep the frequency band and see if that will tell me anything. Remember, this is just the preamp section of this integrated amp. Okay, so I have the frequency response of the unit showing now, and both channels don't look that good. I mean, the roll-off is really bad at the low frequencies, and it's a little bit better at the high frequencies, but both channels are really bad. So I'm thinking that we have some capacitors that have dried out over the years and need to be replaced. So before I get into it a little bit more, I'm going to go ahead and look at just the power amp section and see what that looks like. So right now we're looking at the Kenwood KA-6000 into the main in. So we're looking at just the power amp section of this integrated amplifier, and it really looks pretty good. I'm going to bump up the power just a little bit more. If you watch the signal level I'm putting in, we're at minus 22.8 and our power is increasing. This is rated at 40 watts a channel, and so I don't want to go too much beyond that, but for right now we'll see what happens when we get close. So that's pretty close to 40 watts a channel. You can see the distortions rising up pretty good, but overall it's less than 0.5%, and our signal to noise is pretty good. Our THD plus noise is not outstanding, and we've got a lot of gain in the amp. So the amp section looks okay, and we do see that we have second and third order harmonics are kind of dominating that THD plus noise number, I believe. The 60 Hertz is pretty far down. Anyway, that's the good news, so I can focus on the preamp section and figuring out what the gain difference is.
So this is the schematic for the KA-6000, and our inputs start here and work their way from left to right, going through preamp stages, tone amp stages, and some switches, and there's another filter here on into the main amp, which is a pre-driver to the power amp stage. So what I decided to do, since this preamp board is socketed and real easy to get in and out, I pulled it and replaced all 11 of the electrolytic capacitors in it. Now when I pulled each one, I tested it in my Sencor LC53 capacitor inductor analyzer, and they all tested good. So when I plugged it back in and didn't see any change, I was a little saddened but not surprised. The next thing I decided to look at was this HP 40 Hertz board, and it's fairly easy to get at, although I did have to unsolder one wire from it to get it bent over to where I could look at it. And I replaced all of the electrolytic capacitors on it, of which there are 6. So I replaced all of them, testing them as I went, and they all tested fine. Turned it on and still had the problem. Finally, I went over to the NF tone amp section, which is right here. And let me zoom in on it. Here we go. So I went to this section here, and I ended up finding one capacitor, the C611, the 10 microfarad 16 volt, was open. So I replaced it, and I also replaced the other one on the other side that was still working, but I went ahead and replaced it, although it tested good. And I replaced these two guys here, these 100 microfarad 3.15 volt capacitors. Kind of a weird value, but they were at least 3 volts according to the ones I pulled out, and I put in like 16 volt 100 microfarad caps. So I did that, put it in, and the problem that I originally started with was gone. So both channels had about the same. Yeah! So here we're looking at the preamp output following the replacement of all the capacitors that I mentioned previously, including the key one, which was the C611 on the NF tone amp board. And you can tell that our gains are close now between the two channels, and the THDs are pretty good. The SNR is not as close between the two channels. The left channel does look worse. Let me get rid of that for a moment. You can see the right channel looks pretty clean here as far as the 60 hertz component. But let me click the left channel back on, get rid of the right, and you saw it move. So at 60 hertz, here's 180 hertz, 300 hertz. So that 60 hertz is getting through on this right channel and causing us to have a worse THD plus noise. So I'm going to go back in and try to find a capacitor that's bad, or a ground that didn't get connected, that only is relating to the left channel, and we'll see what happens. So hopefully I'll be able to figure out what is causing the problem and get something that looks more like the right channel, or even better. Our first piece of data is the THD SNR at 1 kilohertz for the auxiliary input to the preamp output. And here we see a much better looking plot than we originally started with. The gains are pretty close for each channel, as are the RMS output voltage. Also, you can see that the THD is fairly low and the SNR is fairly good. Here we have the frequency response for the same conditions as the previous data, the auxiliary input to the preamp output. The volume control is at a 7 out of 10 position as well, and we can see that it looks much better than what we started with. And we've got a flatness of about 1.2 dB across the band. For the left channel, would be very close to the same for the right channel, and the channel balance is about half a dB between the two channels. The difference between the previous frequency response plot and this one is that the previous one had the tone mode control set to bypass both the bass and treble controls, so it was in the off position. This one has both the treble and the bass controls set for 0, but it has selected the bass and treble mode position and looks about a half a dB worse. So here is the THD SNR for the Phono 2 stage, which is the moving magnet stage, and the only spec I could find was it needed to be at least 65 dB of SNR. There wasn't a spec on the THD. I think the THD looks pretty good, and the SNR is close to that. Also, the gains are a bit low for the phono stage, but that's because the amplifier has a bunch of gain. And here is the frequency response of the Phono 2 input. I should point out that the phono measurements are made at the tape monitor record output instead of the preamp output. Anyway, it's basically a 2 dB flatness across the band, or plus or minus 1 dB to be generous. A flatness for the phono stage is not specified in the specs that I was able to find. At this point, I reconnected the pre-out main-in jumpers and went ahead and raised the volume control to 6 and got about 40 watts a channel out. As you can tell, it looks much better than when we originally started with the unit. The one thing that was troublesome was the right THD plus noise, which is about 16 dB worse than the left channels. Overall, the gains look fairly close, and the THDs and SNRs are decent, in my opinion anyway, for this amplifier. While looking through the service manual, I had noticed there were some voltage adjustments for the amplifier section of the KA-6000, and one of them, the center voltage adjustment, it is called, was fairly easy to do, and indeed the right channel's voltage setting was off by several volts, and after I reset it, I got this data, which is so much better than before. You can see the THD plus noises are very close, the gains are very close, the power levels are the same, and the overall THD and SNRs are pretty good. I then decided to push the KA-6000 about as hard as I could before distortion got really bad, and was able to get nearly the spec of 45 watts a channel into 8 ohms, both channels driven, at less than 0.5% THD, so we are there with that requirement, and the SNR was rated at better than 75 dB, so we are better than that. There was no requirement for THD plus noise back then. 50 dB is not very pretty, but you really won't hear it, or at least I wasn't able to hear it when I was doing my testing. Here is the frequency response of the Kenwood, with it operating at 35 watts into 8 ohms. We're using the auxiliary input. The volume control is at position 6 out of 10. And the spec is plus or minus 1 dB from 20 hertz to 50 kilohertz. Now we're only going to 20 kilohertz in this plot, but it did meet the requirement because it's only got about 0.7 of a dB flatness variation across the band. And the channel balance is about 0.3 of a dB, which is fairly good. Here we have the crosstalk between the left and right channels, with the amplifier running at 35 watts a channel into 8 ohms. The input is the left auxiliary input, and the right auxiliary input is terminated into a short. You would like this number to be as low as possible. There is no spec on it. However, I would say that from about maybe 120 hertz to possibly a 10 kilohertz, it doesn't look too bad. And the results look pretty much the same when you use the right channel as the input and terminate the left channel. Here is the effect of switching the 8 kilohertz high filter in, and its spec requirement is 12 dB per octave. Note that only the response for the left channel is shown. Here we have the effect of switching in either the 40 hertz or the 80 hertz low filter, and if you look at it closely enough, you can tell that if you have the 80 hertz filter switched in and you switch in the 40 hertz filter, you're just going to get the 80 hertz filter effect. I am just showing the left channel in this case. The spec requirement is 12 dB per octave. Here we see the effect of switching in the minus 20 dB muting switch, and it's going from about minus, I don't know, 23.5 dB to maybe minus 44.5 dB, so about 21 dB. That's pretty close. Here is a plot showing the effect of switching the loudness contour switch in, and you can tell that it has a greater effect on the low frequency part of the spectrum and not so much on the high frequency, although there is a small boost above 10 kilohertz or so. And that's kind of what I heard when I listened to it, that it definitely had more emphasis on the bass portion of the music that I was listening to than it did the treble portion. This plot shows the effect of the bass control switch, and the spec for it is plus or minus 10 dB in 2 dB increments at 100 Hertz. And we're basically meeting that requirement. It looks to me like it might have just a little bit more gain or loss at the 10 dB position, but overall it's pretty close. Likewise, for the treble control switch, we have a spec of plus or minus 10 dB at 10 kilohertz with 2 dB increments, and it looks pretty close to that. And the last piece of data I have to show you that was taken on the KA-6000 is the multi-tone test data, and from what I understand, this is a decent response.
As I mentioned a little bit earlier, the KA-6000 was really nice to work on. All the pots that you needed to adjust were at the top of the circuit boards. They were labeled clearly, and there aren't a ton of them, but they were easy to get at. The output transistors, should they ever need to be replaced, are socketed, and there is something in the service manual about how to choose the right output transistors if you do need to replace them. Both the owner's manual and the service manual are very well done. All of the circuit boards have metal covers around them, and that helps in shielding from other extraneous signals. And also several of the boards were socketed so you could just pull them out more or less, which really makes working on them a lot easier. Now they do have a lot of solder because they're older circuit boards, so actually removing a component took a little bit more work with the solder sucker and solder wick, but to be able to hold the board in your hand and work on it was pretty easy. Now sometimes you had to cut a few wires to get the board bent back so you could work on it, but even then it still was fairly easy to get at. The wiring was done very nicely. It uses a single 90 volt DC supply rail, and the output transistors are all NPN devices. However, there is a pre-driver PNP device on each stage. So I'm thinking it is a version of Class AB. It also runs fairly cool. After I was doing my listening test, I measured it, the heat sinks, and they were between 125 and 130 degrees F. So they don't get that hot. They don't get that hot when they're just idling like a Class A would be. So I think it's a Class AB amplifier topology. I also checked the ripple on the power supply filter capacitors, and there really wasn't anything substantial at all. I didn't see any reason to replace them. I checked every capacitor that I pulled, and as I mentioned earlier, I only found the one bad capacitor, although I did replace them all while I had it out. But there was the whole main board that had a bunch of capacitors that related to the power amp that I didn't touch. And those filter caps I didn't touch because there was no ripple on them. I'm not somebody who believes in just replacing capacitors on a device because it is of a certain age. That being said, there is an adjustment for the phono preamp's RIAA equalization curve, and I checked it and it was fine. One thing I should mention is that while the KA-6000 has a preamp out and a main amp in, it really is not useful for modern equipment. The reason I say that is the preamp output only puts out about 72 millivolts, or it's a negative 12 or 13 dB of gain. Usually you're going to get a couple dB gain out of a preamp overall, and usually a couple volts of output. The power amp, however, has a gain of 45 dB or so, which is about 20 dB more than you would get out of most modern power amps. So I don't know what specs were at that time, but they were different than today. It works fine as a unit, but if you were to just use the preamp for this for some strange reason, it probably wouldn't work very good for you. The power amp you could use if you had another preamp, but I would see no reason why you would just separate this beauty apart. In researching the KA-6000, all the reviews that I came across from owners just said positive things about it. That was from how it sounded, to its construction, to its durability, to being sad that they got rid of it at some point in their lives. My experience was that it sounded really, really good. Really good. I really enjoyed listening to it, and I have no qualms about the sound. I just listened to it with the volume turned up to maybe 7 and no inputs, just to see how much noise I heard out of my speakers, and I didn't really hear hardly anything. No hum, just a little slight, like a white noise sound that you really had to put your ear close to the mid-range to hear it. For a 45 watt per channel amplifier, I think it sounded great. I hooked it up into my KEF-107 speakers, which are a 4 ohm speaker, and I was able to obtain SPL levels of about 90 dB. Now, to really get things rocking for me, I'm usually up at 100 dB, and this won't get there, but it's pretty loud at 90, and it sounded very good. There was no distortion. It did everything well. I just really enjoyed it, and I'm going to hate giving it back to Ian. As I mentioned before, it did not get hot after listening to it for a while, and I'm just really pleased with it. It does have a good sound. I don't know exactly how to describe it other than there was no flaws that I could attribute to it. So if you're ever at a yard sale, a Goodwill store, an estate sale, and run across one of these for a reasonable price, I would pick it up. You can also find them on eBay. Sometimes they're in need of repair, but it is a real nice unit, and it would be a great daily integrated amplifier to use, as well as just a nice piece to have in your collection if you are into collecting audio gear. Anyway, I thank you for watching. Please leave any comments you may have below, and if you have not subscribed, please do so. Have a great day or night.